Hi, my name is Nicholas Wilcox, and I'm going to be doing my presentation on Alan Turing. So, who was Alan Turing? Well, Alan Turing was an English mathematician, a computer scientist, a logician, cryptanalyst, philosopher, theoretical biologist, and more. I mean, you name it, he was pretty much that. He was highly influential in the development of theoretical computer science, for he created a formalization of the concepts of algorithms and computations with his inventions. So he's considered to be the pioneer and father of both artificial intelligence and theoretical computer science. And for that reason, Alan Turing is arguably one of the most inspirational computer scientists to ever live. Now, he has a pretty big backstory, but we're only going to go over a little piece. And this is going to relate to his perspective. So when he was a little kid, he was always bullied back and forth for A, being too smart, but two, just not really understanding the human communication brain. He couldn't really. He thought it was like cryptology. You know, they would say a sentence, but they would really mean something else through like sarcasm or double meaning, and he never really understood what that second meaning was. And this stuck with him all throughout life, and eventually was applicable to one of his most famous inventions, the Turing test. So, the Turing test is a method of inquiry for artificial intelligence for determining whether a computer is capable enough of thinking and acting like a human being. So, given any computer algorithm, a Turing machine capable of simulating that algorithm's logic can be constructed. So, in other words, it can conclude whether or not the information is human like or computer like given this little strip of input. And then this is the analyzer, and then this is the output, which is going to be the dependent variable on what you're able to tell whether it's human or not. So, one aspect of Turing's formulation, it involves this absolute idea of finiteness. The table of behavior of a Turing machine, it's got to be finite. The length of that tape, it's got to be finite, since Turing has only a finite number of configurations and inputs into the machine. So this is pretty uh, logical when you think about it. Obviously, you can't have an infinitely long piece of input into pretty much anything. So, this is essentially equivalent to allowing only computer programs with finite lengths of code to go into it. So, the tape never holds more than a finite number of marked squares at any point in the computation, obviously. So thus, it can be thought of as being finite, but it is always capable of further extension as required. Obviously, this unbounded extendability it's not physically possible, but the definition is still of practical use. It means that anything done on a finite tape, however large, it's still computable, as long as it's finite. Whoops. So this connects back with his idea that the human brain is finite. So the human memory is necessarily limited. This is his idea. The whole processing method for this machine is to tell whether there's a hint of finite with its logic. Finite, short vocabulary, or the unprofessional syntax, or even a wrong answer. This was all composed of as his analyzation because of his perspective he gained as a child, being bullied by all these people with such finite mindsets. He realized that he was different from others because he acted in a less finite manner. He was always curious. He had a growth mindset. He studied more. He wanted to learn more, and he realized that most humans do not act in that manner, and instead act with little care for limits are held within them. So that's basically how he was able to apply. That's basically where he got his idea for the Turing test, and he applied it by using the necessarily limited mindset to be an indicator as to whether something is human or not. So some final thoughts that I have here: is the human brain necessarily finite? I mean, do you agree with that? And this isn't really a discussion question, but given the new technology we have today, I wonder if this would still work on some of the machinery we have today, because it is far more advanced. But that's pretty much it. Thank you.